All right, hello everyone. My name is Vivek and I am a software developer. I make videos about Kubernetes, containers, Go as a programming language, and software engineering in general. In some of the previous videos, I have set up a basic understanding, or we have discussed about what Kubernetes is and how we can use it to deploy our containerized workloads. But in this particular video, I am going to focus more into services, what are Kubernetes services, and how we can leverage Kubernetes services to talk to other workloads or other pods in our Kubernetes cluster, right? So if we try to define Kubernetes services, again, services are another Kubernetes resources like pod, and services are used to facilitate inter-pod communication, right? In a Kubernetes cluster. In very basic way, we can define Kubernetes services like that. There are some other use cases where you don't actually want to talk to another pod, but you would want to create a service, and we are going to look into that as well. But if we just try to define Kubernetes services, we can say that Kubernetes services are a way to facilitate communication between two pods, right? Or to facilitate inter-pod communication, right? So for example, if you have uh, two layers in your application, front end and back end. If front end wants to, or if front end pod wants to talk to back end pod, in that case we will have to create services, right? And the reason is, so for example, let's say you have front end pod, right, and that wants to talk to back end pod. Now backend pod is obviously going to have an IP, right? And front end can actually talk to the backend pod using this IP as well, right? But the problem with this particular approach is, if pod restarts, right? Pods are ephemeral entities, I would say. They can get deleted, and or they can be restarted, and their IP would change. So if front end pod is very dependent on the IP of the backend pod, in that case, if the backend pod restarts, the IP would be changed, and front end pod would no longer be able to talk to the backend pod. So these are some of the reasons why we cannot use the pod's IP, and this is where service helps us, right? So in other words, we can say that services abstract a set of pods, right? So let's say if we try to create service in front of the backend pod, right, we can use this particular service to talk to the backend pods. And let's say there are three replicas of backend pods. Service would successfully be able to redirect the traffic to those three pods, right? So yeah, I mean, again, if we try to define service once again in very short, we can say that service is a way to, or service Kubernetes resources help us uh, to talk to another pods in our Kubernetes cluster, and they obviously abstract a set of pods logically. So for example, here we talked about, if there are three replicas of backend pod service, we can expose those pods using service, and then front end would talk to service. And even if the backend pods are restarted, since we are accessing backend pods using this particular service name, the connectivity between front end and back end would not actually be hampered, right? So this is the reason why we should use services to talk to another pods, right? And another reason is, we have a very good decoupled system here. So front end is not actually coupled or tightly coupled with the backend here, because we are accessing backend with service, and even if backend pod restarts, its IP changes, front end is not going to get affected, right? So this is the reason why we should use services to talk to other pods in our system, right? Now if we talk about how do we actually define a service, right? So we have already written this application in some of our last videos, where we have two layers, a REST API and the database. REST API talks to the database, right? So I have already deployed that application in this particular DigitalOcean cluster that I have just created. So creating a Kubernetes cluster on DigitalOcean is very easy. I would say you just have to click on some buttons, and that's what I did. So this is the cluster that I have, and I have already created two namespaces, database and REST API. So database is where our database is running, and REST API namespace is where our REST API application is running, right? So now let's just go ahead and try to see how do we actually define a service, right? So if we try to have a look into everything that is in REST API namespace, we can see that we have a REST API pod running, and we have a deployment named REST API that is managing this particular pod, right? Just to make sure that things are working as expected, let me quickly go ahead and try to port forward the traffic to this particular pod, just to make sure that we are able to talk to the database and everything is working as expected. So kubectl port forward to namespace REST API and to pod, this particular pod, right? And on port, let's say 8080. And if I just go ahead and try to access the things on localhost 8080, we should be able to see some books that are there in the database, right? And I have a detailed video about this, how do we actually write it and deploy it on Kubernetes. So maybe you can check that out. So now that we know we are able to access the API by querying the pod, now let's just go ahead and try to see or try to look into how we can define a service, right? So the command line that we can use, or the command that we can use to create a service manifest is, let's say, kubectl expose, and the deployment that we want to expose, right? So in this particular case, we want to expose a deployment named REST API, right? So, and that is in REST API namespace. And so this is pretty much it, right? And by default a service of type cluster IP is going to get created, but we are going to look into what are all the types that Kubernetes supports, right? So if we just press enter here, or we don't actually want to create the service, we want to actually look into the manifest, and let's say we say it service, or let's just go ahead and create another directory. So service hyphen, and now if I expose deployment from REST API namespace named REST API, right? And we don't actually want to create that. Okay, and the port that we want to expose is, let's say, 8080, right? And if we go ahead and try to look into the service, manifest, now this is how we define a service. So like any other Kubernetes object, we have API version, kind, or type meta, and this is object meta, right? This is type meta, this is object meta, and then standard spec stuff, right? So here we can see that this particular service is going to redirect or going to forward the request that comes to this particular service on port 8080 to the pods that have this particular label on target port 8080, right? So this is what this particular service is going to do. So if we just go ahead and try to create the service now, in the REST API namespace, right? So once the service is created, and if we try to have a look into the services from REST API namespace, we can see that we just created this particular service, right? And this service got a cluster IP that we discussed about. So cluster IP is the type of service that gets created by default. So again, if we have a look into this particular manifest, this is how we define a service. So I mean, this port is the port the service is listening on, right? And this port is the port where the traffic would be forwarded to, or the traffic would be redirected to. So target port is the port where the pods are listening at, right? And all the pods where this service is going to forward the request to are the pods that have app colon or app equals to REST API labels it, right? So yeah, this is how we actually define a service. I have written down the things that I want to discuss about in another screen, so that's why I'm looking that way sometimes. So this is how we actually try to define a service, right? And if we define a service, there is another resource that gets created, and that is the resource that actually stores the pod IPs where the request should be forwarded to, right? So if we try to have a look into all the pods in REST API namespace, we can see that we have this particular pod running, and this pod has this particular IP. This service does not actually have the IP of this particular pod, right? And that is where this another resource endpoints help us. So get endpoints from REST API namespace, and this is the name, this is the resource that actually has to which particular IP we have to forward the request to, right? So in this particular case, we can see that this is the IP where this particular service is going to forward the request to, right? Now there is, if we talk about services, and we have already discussed about controllers, so there is this controller, I think named service controller, that scans or that queries API server for the pods, right, with the particular label that this particular service is supposed to manage, right? So for example, this particular service is supposed to manage all the pods with label app equals to REST API. So service controller would actually scan all the pods, and if there is any other pod added to that list, that IP would be added automatically here, right? So if we just go ahead and try to scale the deployment, so if we try to get the pods from REST API namespace, we can see that this namespace just has one pod with this particular IP, and that is why in the endpoints we are only able to see one IP, right? If we just go ahead and try to scale the deployment, right, from REST API namespace, right, to let's say 3 replicas, right? And as soon as those 3 pods are added, we should be able to, or we would be able to see those extra 2 IPs in this particular list. So let's just go ahead and try to do that. And if I try to get pods from REST API namespace, once again we can see that these 3 pods are up and running. And now if I just go ahead and try to access the endpoint resource once again, we would be able to see these 2 endpoints. Again, we are not seeing this third endpoint because this particular pod is not up and running yet. If we wait for a second, now if I just access endpoints from REST API namespace, we are able to see these 3 IPs, right? And this is being taken care by service controller, right? So service controller just scans the pod that are matching the label that is defined in the service, and then adds the IP into this particular list, right? Now how the service is redirecting or forwarding the traffic to this particular IPs are dependent, or this particular mechanism is dependent on how kube proxy is configured, right? And that is that needs another video, so we are going to look into that a bit more detail in another video. But right now, so for example, if a request comes to this particular service that we have, how, which particular pod this service is going to forward the request to. So there are a lot of ways. For example, the request can be forwarded to in round robin fashion, or to the pod that has least connections, right? So these are some algorithms, and that totally depends on which particular mode the kube proxy is running on, right? So yeah, I mean, this is about service controllers and how do we actually define a service, right? So yeah, now if we have a look into, if we have a look into the service once again, or definition of service once again, we can see here the target port is 8080, right? So or what we can do is, in some cases we can actually name the ports. So for example, if we have a look into the deployment here, so if we talk about this particular deployment, we don't actually we have not actually specified the port here, but if we specify a port and we name that port something. So for example, if we specify a port here, right? Again, I'm not sure about the syntax, so I'm just writing it over here, but you would get the idea. So let's say if I say port type is, let's say, TCP, and name is let's say TCP port, right? And value is, let's say, 8080. So in that particular case, like in the service, we are actually targeting the port 8080, right? Or what we can do is we can actually target this port with the name as well. So for example, TCP port, right? So in some cases we can actually target the port, or in services we can actually specify the name of the port as well, right? And the benefit of doing that is, if we let's say, if we change our application to make it to listen on another port, for example, today it was listening on 8080, but tomorrow, let's say, it started listening on 33, let's say, not 6. In that case, we would not actually have to change the services manifest, because in this particular case we have specified TCP port, right? And TCP port refers to 3306 now. So this is another way of defining a service, where we can actually define a target port's name instead of the port's value, right? So yeah, this was about how do we actually define the ports, right? And if we talk about another way, so for example, we can see here this particular service has a selector, right? But in Kubernetes, we can actually create services even without selectors, right? So for example, if we talk about this particular scenario that we just saw, in this particular scenario, all when we created a service, a respective endpoints resource was created, right? Because service controller was able to figure out the pods with the selector that is defined in the service, right? If if service controller is not able to figure out pods with the selector that is defined in the service, endpoints resources will not be created. So first of all, let's just scale this deployment back to 1, and what we are going to do is, in this particular service, let's say we are going to edit the service from REST API namespace, and if we change the selector to, let's say, REST API new, right? And now what service controller is going to do is, service controller is going to look for all the pods that have the label REST API -new, and we don't have any such pod in our namespace, right? So in that particular case, if we go ahead and try to look for endpoints, we can see that the endpoints resource does not actually have any IPs, right? And because this endpoint was already created, we actually see the endpoints. But if we create a new service without any selector or without a selector, I don't think this uh, yeah. So if we create a service with a selector and pods were not found with that particular selector, the IPs would not be listed here, right? And the another thing that I want to discuss about is there are chances that we want to specify the endpoints manually, right? So for example, we have actually created a service, right? So services are a way using which we are going to access a workload, right? But if we define a selector, that service is going to redirect the traffic to those particular pods, right? But for example, let's say I want to access something using the service, but I want to define where that service is going to redirect the request to, right? So for example, in that particular case, what we can do is we can create let's just go ahead and try to edit this service once again, just to uh, make things as they were before, right? So now let's just go ahead and if I try to create a service, so expose, let's say, uh, or let's say if I just copy this entire thing, right? And if I save it with the name service without selector.yaml, and if I remove this selector, right? Let's see what happens now. And let's just go ahead and try to create it in the default namespace. Okay, so now if we have a look into the services from default namespace, we can see that this is the service that we just created right now. If we go ahead and try to have a look into the endpoints resource from default namespace, we are not able to see any endpoint, right? Because we have not specified the selector, right? So now we have this way, or we can leverage endpoints to specify any IP or any workload that we want to forward the request to. So for example, we can just go ahead and try to create an endpoint resource manually, and in that endpoint resource we can specify which particular IP this service is going to forward the request to, right? So for example, let's say you have a database running on a, on let's say an instance that is not in your Kubernetes cluster. Let's say you are running a managed database and you have IP of that managed database, right? And you want to access that database using Kubernetes service, right? So yeah, you are going to create the service without the selector, right? But you are going to create the endpoint, because services use endpoints resources to figure out where do I actually have to forward the request to, right? So in that case, we can actually create endpoint resource manually, right? So if I just go ahead and try to uh, look into the endpoint resource from REST API namespace, so in this particular case, we can actually specify the so it has the address, right? Address of the pod where the request should be forwarded to. But what we can do is we can actually specify any address that we want to, right? And this is why, or this is the use case where we can use services without selectors. So for example, let's say you want to forward the request to a specific IP, right? So if you use service with selectors, in that case, the traffic would be forwarded to the pods that match those selectors. But if you want to manually define the IP, you can create services without selectors, and then you can create the endpoint resources manually, right? So yeah, this was about services without selectors. And now if we just go ahead and try to look into how do we actually, let's say we have created a service, right? And we have seen how do we create services, what are services without selectors. Now if we talk about how do we actually access a service, right? So let's say in the REST API, in the REST API namespace, we have this service, right? And let's say we have to, or we want to access this particular service from another pod, right? So there are two ways to do that, right? One way is to actually use environment variables, and another way is to use DNS, right? So we are going to look into both of these in detail. So for example, if you talk about the first way, that is environment variables. So let's say there are two ways. One is environment variable and another one is DNS, right? So we are going to look into environment variable way of accessing the services. So for example, let's say I have this service, right, in REST API namespace, right, named REST API. Now, if I just go ahead and try to create a pod, okay, if we just go ahead and try to create a pod in default namespace, right? So this is just going to create a pod in default namespace, and the thing that I want to emphasize on is service is already created, right? And then we are going to create the pod, right? So in this particular case, what kubelet would do is kubelet is actually going to set some environment variables in this particular pod, right? So for example, from this particular pod you want to access this service, right? So in that case, if the service is already created and you create the pod later, in that particular case, kubelet is, because kubelet runs on every node, right? And this particular pod is going to be scheduled on a specific node. So kubelet is actually going to set an environment variable with this particular, for this particular service on this particular pod. So let's just go ahead and try to have a look into this. How does that actually happen? So if we just go ahead and try to create the service, or pod, let's just go ahead and try to exec into that pod. So kubectl exec -it, right? And if we have a look into all the environments that are set here, we can see that these environment variables are already set, right? REST API service host and REST API service port should also be there, REST API port, and things like that. So here we can see every detail about that service that we see here has been set as an environment variable into the pod. But the only thing is, this particular pod, the client pod or the pod from where you are going to access the service, should be created after the service has already been created, right? So again, if I try to summarize this, let's say you want to access a particular service from a client pod, right? In that particular case, if you create the pod after the service is created, kubelet is going to inject some environment variables in your pod, and using those environment variables you can actually access this particular service, right? So yeah, I mean, this is one way of accessing the services, right? The another way of accessing the services is DNS, right? So let's say you don't actually want to rely on this because the drawback is, let's say if the client pod is created before the service is created, in that case you won't actually have those environment variables, right? So this ordering issue can be resolved if we try to access the services using DNS, right? So this is the way that is followed when we try to access other services using DNS. So for example, service name dot namespace name, right, dot svc dot cluster dot local, right? So this is the DNS that is followed when we try to access the services using DNS name, right? Again, we will have to install DNS server, and that is why we need core DNS, right? Again, we are going to discuss about this in another video that I'm going to make about Kubernetes networking, but DNS server should be installed on your cluster so that this particular DNS would be resolved to the actual IPs, right? Otherwise, this particular DNS would not be resolved, right? So this is another way of accessing the services. So if we just go ahead and try to exit into this pod, nginx bash, and if we curl that particular service, so curl, and the service's name is REST API, and in the namespace REST API, right? Dot svc dot cluster dot local. Let's see. Okay, so we see here 404 page not found because our API is listening on APIs slash v1 slash books, right? And again, we are able to see the book that is there in the database. So this is the second way of accessing the services, that is service name dot namespace name dot svc dot cluster dot local. The other thing that we discussed about, so for example, the environment variable way, let's just try to use that as a, so REST API service host is this, so curl to this particular service, API service port is 8080. Okay, so things should work. Alright, so after spending some time, what I figured out is the reason is we see that the IP here and the actual IP of the service is different, right? And then I thought maybe the reason is the client pod that we are on right now is in default namespace, but our service is in REST API namespace, right? So let's just go ahead and try to run the client pod in REST API namespace, and then we are going to look into how we can use the environment variable way to access the service. So nginx, right, and in the namespace REST API, right? Okay, so exec hyphen id hyphen n so this is the pod, let's say we want to exec into, right? And now if I have a look into the environment variables, we can see that now the environment variables are correct. So for example, for REST API, the host is 10 .245.138.138, right? And if I try to access the things now, so curl colon port, we see the correct error messages. Here we go, right? So these are the two ways using which you can actually discover the services, right? And again, we saw that there are issues, there are problem with the environment variable way, because the client pod should be created after the service has already been created, right? So we people, I have seen people preferring the DNS way of accessing the services almost all the times, right? So yeah, now that we have seen a lot of things about services, why do we actually use them, it's time to just go ahead and try to have a look into what are all the kinds of services that Kubernetes provides us with, and in which particular case we should use which one, right? So the first service, that the type of services that Kubernetes provides us with is ClusterIP, right? The IP that we have just seen, or the service that we have just seen, and the service that we were playing around. The other thing is, or other type is NodePort, and the third type is load balancer, and the other one is external name, right? So this is a service that we have been looking into up until now, and this is, I would say, usually most common service that people create, because to facilitate interpod communication, because it gets you the IP, and if a DNS server is installed using core DNS on your cluster, you can use DNS Way to access the services very very easily, right? So this is the service that we have been seeing up until now, and this is the service that is very frequently used to facilitate interpod communication. So if one pod wants to talk to another pod, we just go ahead and try to create a cluster IP type of service, so that the source pod, or from source pod, we can talk to the target pod. If we talk about NodePort type of service, so again, as the name suggests, if we create a service of type NodePort, we can access the service, right, using the node's IP address, right? So for example, if we create a NodePort type service to expose our REST API, right, in that particular case we can actually access our REST API from outside of our cluster, from the public internet, by using the node's IP addresses, right? So this particular type of service, we can say, is used in the cases when we want to expose our service outside of the cluster, right? So that the service can be accessed using the node's IP, right? So for example, let's just go ahead and try to, if we have a look into all the things that we have in REST API namespace, so let's just delete the unwanted things. For example, the nginx namespace that we don't want, and we would also want to delete the pod, right, that we don't want, nginx pod, right? And after that, if we have a look into all the things from REST API namespace, we can see that we have a service of cluster IP of type cluster IP, and deployment, and things like that. Now we want to use another type of service, that is NodePort, that we discussed about, and using that NodePort type of service, we are going to access our application from outside the cluster, right? So up until now we were spinning up a pod in the same cluster, and from that pod we were trying to access REST API service, because the service that we created was of type cluster IP, right? Now if I just go ahead and try to expose again to create a service, we can either use command line utility, or we can use this to generate the manifest and then apply the manifest. So expose the deployment from REST API namespace, and name of the deployment is REST API, right? And the type of service that we are going to create is NodePort, right? And let's just try to generate the manifest. So NodePort.yaml. If I enter it, we will have to specify the port flag, right? So 8080. Now if we just go ahead and try to have a look into the service manifest that just has been generated, so NodePort.yaml, right? So here we can clearly see that this particular service is going to target the pods on port 8080 and the pods that have this particular label set, and our pods, our REST API pods, have this particular label, right? So let's just go ahead and try to create this service, and this service is going to be created in REST API namespace, right? So after creating this particular service, if we so name of the service is going to be REST API NodePort, and if we list all the services from REST API namespace, we can see that this service has been created, right, of type NodePort, and this service has a cluster IP, but we can access this particular service using the node's IP addresses, and this particular random port has been opened up on the nodes. Now let's say we have multi-node cluster, right? So these many nodes, we have these many nodes in the cluster, and there are chances that the pod where this service is supposed to forward the request to is on one of the nodes. So even in that particular case, we don't have to worry about anything. We can access this particular service using any of the nodes IP address. So if I just go ahead and try to see the IP address of these nodes, now to access this particular service, all I have to do is IP:port, right? So let's just go ahead and try to do that. So IP colon, and the port where this particular service is listening on is this, right? And here we go. So 404, if I just go ahead and APIs v1 books, right? So here we go, we are able to actually access the service that is in the cluster from outside the cluster, right? Now we are on our public internet, and from that we are actually able to access the service. Similarly, if we try to use another IP, we can do that as well. So right, and similarly, if we use another IP, another node IP, we can do that as well. Hold on. So yeah, I mean, obviously we don't have SSL, but you get the idea, right? So this is how we can leverage a service of type NodePort to actually access or expose the service, expose the workloads outside of the cluster, right? Now the other thing, or the other type of the service is load balancer, right? So this is also one of the most used services in the cases where we want to expose our workload, our pod outside of the cluster, right? So if we just go ahead and try to create a service of this type, In the case of NodePort, we have seen that a port in every node of the cluster is opened, and to that we can access the service using the node's IP, and that dynamically or randomly generated port, right? In the case of load balancer, if you are on cloud environments, a load balancer would be created automatically, and this is where cloud controller managers come into picture. From if you remember our or one of previous videos, we have discussed about cloud controller managers, right? And this is where cloud controller managers come into picture. So if we create a service of type load balancer, in that particular case, cloud controller manager is actually going to create a load balancer, and then if we try to access that load balancer, we will actually be able to access the service, right? I am not sure why this third IP address is not working. But anyway, you get the idea, right? We are able to access, we will be able to access the service from any node IP that we want to, right? So now let's just go ahead and try to create another type of service, that is load balancer, right? So for example, expose deployment from REST API namespace. Name of this service is going to be REST API hyphen load balancer, right? and and we don't actually want to create it. Let's generate YAML, right? And if I just go ahead and try to create this particular right, if I just go ahead and try to create this particular service, so this is how the service looks like, right? So name is REST API balancer, this is the target port, these are all the selectors. Now the best thing about this particular service is, if we just go, this is where our cluster resides, right? If we go to networking and then load balancers, we should be able to see a load balancer being created here. So I'm going to change the namespace just to keep things easy. Namespace to REST API, and if we create the service now, so here we see REST API balancer service has been created. Okay, so we have not specified the type, right? And that is the problem. So we have named the service to be REST API balancer, but we have not specified the type here, and that is the reason we did not actually see any load balancer being spinned up, right? So let's just go ahead and try to remove this file, and then we expose the deployment once again, but this time we are going to actually specify the type, right? And if we create this service now, the type of service would be load balancer, and a public load balancer would be created on DigitalOcean. So create -f and service -load, and this, I want to get this created in REST API namespace. Right Now we can, if we list all the services from REST API namespace, we can see that this service is of type load balancer and external IP is pending, and the reason is we can see here the load balancer is being spun up, right? So this is how you can use uh, service of type load balancer to expose your workload outside of the cluster. Now this load balancer can be accessed from anywhere that you want to, right? So let's just wait for this particular load balancer to get created, and then we can access the REST API using IP of this particular load balancer, right? And then we are going to discuss about external name, right? So this may take some time. Let's just wait for this. This is the page where you are going to find everything that I have just discussed about. Maybe I will be linking that in the description. So again, we are seeing the external IP to be pending, and as soon as this load balancer creation is completed, we should be able to see the external IP here, right? And this is the way usually people expose their applications, using the combination of, let's say, load balancer services and ingresses. So ingress is another topic that we can discuss about maybe in another videos. Okay, so this is the IP address, and if I try to query this, we are not getting anything. But if we try to access that using the port that we have, okay, API/p1/books, and here we go. Now we are accessing the service that is there in our cluster. So kget service or kget all-n REST API. Now we are accessing, or we are making request to this particular pod using the load balancer that was dynamically created in DigitalOcean, right? So this is the use case. This is how we can use different type of services to access your workloads. Now if we talk about service of type external name, right? Now let's just go ahead and try to have a look into this. So the use case of external name is, for example, you want to redirect or you want to for example, you want to resolve a specific DNS, for example, Vivek's website, right, to, let's say, viveksingh.dev, right? So this is what you want to do. You want to resolve this particular name, Vivek's website, to this particular website, right? So this is the use case where we can use a service of type external name. So in your Kubernetes cluster, you are going to create a service with name Vivek's website, right? But in the spec, you can define that this particular service is going to resolve to this particular DNS, right? So let's just go ahead and try to have a look into this as well. So kubectl create service hyphen type external name. Try run. I have not run this command earlier. Let's just see if it works. txt name.yaml. Okay, no issues. So let's just go ahead and try to have a look into the documentation. And let's see how do we actually create. Yeah, so this is how we create a service of type external name, right? So and if we just go ahead and try to, let's say, change this to viveksingh.dev, it simply means that if I try to access my service, this should be resolved to this particular DNS, right? And if I just go ahead and try to create this in, let's say REST API namespace, right? Okay, so now if I access everything from REST API namespace, we can see that we have created a service named my service. Type of this service is external name, and this is the DNS that this service is going to resolve to. Now to test this, let's just exec into the pod. We don't have any pod, so kubectl exec. Okay, right, now that we are inside this particular pod, let's just check if we try to access my service, this particular service is actually resolving to viveksingh.dev, right? So we are going to use this utility called dig is not installed here, so let's just go ahead and try to upgrade the things. So this might take a bit. So I'm doing this just to have this dig utility that can be used to resolve that service. So now that we have dig installed here, what we can do is dig my service, right, dot REST API dot svc dot cluster dot local, and if everything goes fine, here we go. So this particular service that we have specified here is being resolved to the domain that we have specified in that service, right? So yeah, I mean, this was pretty much it about the services. How do we facilitate interpod communication? This is pretty long video, I would say, but I think, yeah, I mean, if it makes sense to you, the length would be worth it, I think. So if I just try to summarize the types once again, ClusterIP is basically or mostly used to facilitate interpod communication inside the cluster. NodePort is used if in the cases you want to expose your workload outside of the cluster. So a port in the node would randomly be selected or chosen, and we can access the service using node's IP, any of the node's IP and the port. And load balancer actually creates a public load balancer on the cloud provider, and external name is used when we want to resolve a particular service name to an actual external DNS, right? So this was pretty much it about the services, what I wanted to talk about the services. If you liked this video, you should consider subscribing. You can follow me on Twitter, I'm pretty active there. And if you want to discuss about something, you have any question, confusion, we can chat about that either in the comment section or any way you want to. I mean, Twitter, Insta, any way you want to. So yeah, this was pretty much it. Thanks for watching.